Welcome to our first ever lecture series, Cisco's Certified Network Associate Guide Day 1. So, what we are going to cover for today's episode will be focusing more on the network fundamentals, why do we need to study network, and of course, overview of the CCNA topics for 2025. So, this whole series, I'm assuming that uh, you guys are watching this because we don't have prior knowledge to network, or if we do, we only have minimal knowledge about the industry itself, the network industry. Because main reason why I started this series or this content is way back when I was like I just graduated in college. Like this is me, graduated in college. Um, for someone who graduated in the field of technology, you don't know which path to take. Like there's so many options back even back then, but it seems like it's hard to know to pick a specialization on a certain field. And all I know back then is that I don't like to code. I don't like to program. So anything related to technology, to IT, that doesn't have any code, that's where where I'm focusing on the job posting sites way back when I was, or when I just graduated in college. And then luckily, um, I was accepted as a technical. Sorry for my handwriting here. It's hard to navigate using my mouse. I was accepted as a technical support, and on that role, I was able to access Cisco devices, able to configure switches and routers, and that's where my networking journey started. Fast forward, I jump into network engineering role for ISP. I am also have a network engineering role in BPO industry, and right now I'm working as a data center operations for financial services. Okay, so um, this course, we're going to focus on the network itself, how to ready you guys to have a position in on the field that you'd like to choose, especially if it's about networks, because the course that we're going to deal, or this whole series would be about CCNA, so it's about networking. Okay, so let's start the discussion. So this will be very basic. I'll start with the terms, so please bear with me with the definitions, and why do we need to know all of this stuff. And then as we progress with the series, we're also going to start with the configurations on those Cisco devices. Okay, so for starter, so by definition, it says that a network is the combination of two or more computing devices and their connecting links. So we can say that network is anything, or as long as there would be devices connected to each other. So a network could be as small as the one that you're seeing right now, like these two images, like one PC, second PC, and they're able to connect to each other. And most of the time, we're only familiar with the IP addresses, but we're also going to discuss that further as we progress with this series. And to give you guys a real world example, like let's say we're trying to access our um, Facebook. So this will be the common setup whenever we are browsing on our computers or on our machines. So you have your computer, and that computer, you're going to access like maybe a browser, right? So you'll be accessing a browser here, and then after you access a browser, what you need to do is that you'll be making sure that you are connected to the internet, which is the Wi-Fi, the ISP, and then that ISP will connect you to what we know the internet, right? And if we're accessing Facebook, that internet will route you over to a certain data center where that Facebook application system is deployed. So this will be a data center, and you just need to be routed to a Facebook server. So this is the whole uh, like internet, simple internet architecture on how we browse through our uh, browser, right? So this is the setup. Now, for the network, what we need to understand is how would we explain this connectivity from your PC going to the internet. So this is what we're going to focus on, like to understand what this how this communication happens from your computer going to a server, which is like a server for Facebook. Now, in the IT industry or in network, there's this concept, the OSI model. So it's a reference model. It's a framework. So OSI, so it stands for Open Systems Interconnection. Even before, when I'm just starting on my career, it's always the OSI model is used to explain connectivity from one end to another. But please take note that OSI, it's more on say it's more on theory. It's just like the um, step by step procedure on how can we explain uh, the connectivity from your, let's say for this one, from your computer going to a server. So what's an OSI model? So if you're going to, even if you're going to browse on the internet, the OSI model, it consists of 7 layers. This always being asked even on technical interviews. I believe even until now, these are always the questions that that are getting by the fresh graduates, especially if they're jumping into network role. So what's an OSI model? So it started with the physical layer. There's a physical component. So let's redraw the image a while ago. So the physical layer of the OSI, so it means that's your machine, the computer itself, the physical component of your machine. So when and then on the next step, it says here data link. So every machine that we have right now, it has a MAC address, right? So that MAC address that is converted into frames. Remember that when we started computers, it started with binary, like the beats, like the 11001 beats to send communication from to device. So that's still the same. Like it explained, okay, from bits that we're getting from the physical machine, that will be converted into frames, which is under on the layer 2 or data link layer. And then once we have that frames, or under that frame, it will include even the MAC address on it. So once you have the bits, then transferred to the frames, that would be the layer 2, and then you're going to have the network layer. So on the network layer, this is where IP addresses are used. And ISP, the primary reason why we do have an ISP is because of the IP addresses that they provide to us. So take note that we do have like a public IP, and also we have a private IP. So for ISP, so if you are connected to your local provider, like on your home network, most likely you don't know the public IP that was being provided, but because it's I mean, it will be randomly distributed to all its client, especially if it's not an enterprise setup, because public IP, so a public IP that's managed by some sort of organization. I believe that's Ayana. And then in order for you to get IP, that will cost you a lot. So there are organizations here that um, allocate those IPs to our ISP, to our service provider. So the main purpose of ISP is for us to connect to their network, and then on their network they will be providing that public IP so that you're able to connect to the internet. Okay, so the ISP, that's where the network layer, it will provide you the IP address. And then for the transport layer, so TCP and UDP, so these are the common transport layer that we have. We're not going to deep dive on this one, but off review on this one. So TCP, it's connection oriented protocol. So UDP is it's a connection less oriented. So most of the time we're using TCP to create connectivity to a certain location. So UDP, it's a connectionless, it's much faster, but it's a connectionless protocol. So usually we're using this one if we're doing broadcast. It's like we don't care about the or like we don't care about the receiver if they're going to receive the data that we're sending them. Now for the session and presentation, so this goes with the encryption part, like the SSL. Something goes with the back end and how the encryption and decryption happening from one device to another. So those are the session and the presentation part. And lastly, the application. This is where we have most access with. So for the application layer, so we're using most of the time, if it's a browser, HTTPS. So that's how we explain the connectivity from your local PC going to Facebook server by following the OSI model. Though this one, it's more on a theory side, so we're not going to really deep dive on the nitty gritty of it. But it's good to know that okay, this is the part of the OSI model that where this connectivity happens. Now, that's enough for the like the explanation of the one end to another. Now going to some topics that we have for CCNA. So these are the topics that I get on their website. So you can get the all the topics, the CCNA topics that they do have. So it's the routers, layer 2 and layer 3 switches, next generation firewalls, access point controllers, endpoint servers, and PoE. Like explain this one by one. So for routers, so once we sorted with the configuration, this is where we declare or how well by the term itself, routers, this is where we set up the routing for a specific IP. Because right now, if we're going to check, let's say the application, let's open our command prompt. So if we're going to, let's say, ping facebook.com, you'll see the IP address of that Facebook, that 167.70.130.35. And in router, we're the one who's going to define, let's say, how to get to well, I hope you just don't read this one. Just focus on my words. It's really hard to write in my using mouse. So how to get to this IP. So in router, that's where we set up, okay, I'm going to set up that these IPs, let's say 163.71.30.35 will go to this path. So that's how routers work. So it will let you decide how would you route traffic, how would you decide which path that this specific IP will go into. Next, we have layer 2 and layer 3 switches. So layer 2 and layer 3 switches, it came from the OSI. If we're going to go back to this OSI model, we know that the network layer, this is where the IP. So if we're talking about layer 3 switches, it means that there are IPs involved, there are routings involved on that device. That's why it's called layer 3 switches. And then layer 2 switches, most of the time, it's just like a plug and play kind of device. So you have a switch. So a switch is it's a device with a multiple port wherein you can connect cabling that will be connected to your computer. So if you decided to put routing on this one, we can consider it as a layer 3 switches. If it's just a plug and play, we can consider it as a layer 2 device. So layer 2 because it doesn't have IP, layer 3 because if we're going to look at the OSI model, that's where the network is located, and that's where the IP address is, the part wherein the IP address of the communication from one device to another. So access points, for access points, it's almost the same with Wi-Fi. It's just more on the enterprise level. You have your let's say your access point here, and on the access point there will be a certain controller wherein you can manage those access points, or we can consider it as Wi-Fi, but there are just more features on it, like enterprise level and also the coverage of the access point. We're going to deep dive on those topics once we get into the configuration side. Now for controllers, this is actually a new technology from Cisco, because when I started my CCNA, I don't remember that we already have like the controllers or like the DNA center. I don't think it's already part of the topics once when I took my CCNA. So this one is a new, but the concept of controllers right now, just to give you an idea. So before, let's say you have a router here, all the configuration routing is under this device. So if this device fails, all the routing, all the processing, this is processing, this is routing, will be terminated. Now with controllers, this is how we set up network right now. So you have your physical device, let's say this is your physical device, and then you will have a controller that will manage the routing of all those devices. So right now, these devices, the only thing that they're doing would be just to really send packets and also receive packets, and all the configuration and routing will be connected to a certain device, which is called as controllers. And endpoints, there are many example of endpoints, but the endpoints that I'm seeing right now, probably it's the user itself, how the connectivity from a certain user going to the network infrastructure. And also we have servers and PoE. So for servers and PoE, for servers, I'm not sure if this is the PoE that I still remember, but I'm going to look on to this part. But for servers, I would just explain servers as it's just another form of computer. So if you're going to have a computer, and then let's say you have a server, so this server, this is where those applications reside. Like our example, on a data center, that's where those servers are located, and those servers, there would be applications that are being hosted in there. And for PoE, power over Ethernet, I'm not sure if it's the same that I do have before, but like the port wherein you're going to have the device open. Let's try to check. POE Cisco. Okay. Okay, so it's the same that they do have before. So um, PoE, power over Ethernet, meaning that you can connect devices on a certain port, like let's say on the switch, for example on this one, the switch before, let's say on the switch you're connected the access point, and on that access point you have to plug it on a certain outlet. With PoE, based on the definition, it's a technology delivering DC power to devices over copper Ethernet. So it's still the same that I've studied before. So meaning you don't have to use this power outlet, and you just have to connect to the Ethernet cabling, and it will be able to power up that device. So these are the very first topics for CCNA. Though it's an overview of all of the topics that we'll be discussing, but it's good to know that okay, you can go to this website and check what are the topics that currently have for CCNA 2025. But we're going to create more episodes focusing on each of these topics, and also start with the configuration part uh, of this CCNA series. Okay, and I think that's for today. Thank you so much for tuning in to my first ever lecture series for CCNA 2025. Again, thank you guys. Bye bye.